Hi, hi, hi. Today we shall be developing vector auto regressive auto reg, reg, auto regressive model, which is known as a VAR model. And we have three variables such as edu, then GDP, and INV. What is edu? Here edu means education, right? That is education. And then we have the GDP, that is gross domestic product. And what is INV? INV is the investment. So we have these three variables to develop vector auto regressive model, VAR model. And we have the data here. You can see the data. So it is the observation from 1980 until 2010, right? And that is the data of edu, GDP, and INV. We have these three data that we have so far, right? Okay. And we assume that all these variables are non-stationary, but when we convert all these variables into first difference, then they become stationary. That we assume without testing. So when this thing happens, then we can run the Johanson cointegration test, right? Okay, so first we shall run the Johanson cointegration test, because edu, GDP, and INV, these three variables are non-stationary, but when I convert them into first difference, then they will become stationary. So we can run the Johanson test of cointegrations, meaning that the variables are integrated of same order, meaning that they are non-stationary, but after first difference they become stationary, meaning that variables are integrated of same order. So when the variables are integrated of same order, then we can run the Johanson test of cointegrations, and that we shall do now first. Okay, so first I go to statistics to do it. So I go to statistics, right? I click on the statistics, then multivariate time series. Then I go to the cointegrating rank of a VECM. Okay. So then I set the variables. First I take edu, GDP and INV, and here I take the constant, and here time settings. Okay, here I put the observation, and our data is yearly data. So I select year, then okay. Then I also click on the reporting. I select report maximum eigenvalue statistics. I select it. Then I go to model, and here I take maximum lag 3. Suppose lag selection criteria has advised me to take maximum lag 3. So I have taken lag 3. So the model is set. So we can proceed. So these are the outcomes of the Johanson test for cointegration. So now what is our null hypothesis? First I set my null hypothesis, and what is the null hypothesis? There is no cointegration, that is null hypothesis. And what is alternative hypothesis? There is cointegration among variables, that is alternative hypothesis. Okay, so here you can say maximum rank. So 0. What is 0? That is the null hypothesis. That means there is no cointegration. So that is 0. And here you can see trace statistics and critical value, and the trace statistics is 26.38 and critical value is 29.68. So what is the guideline? The guideline is when the trace statistics is more than critical value, we can reject null hypothesis and can accept alternative hypothesis. But if the trace statistics is less than critical value, we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that there is no cointegration, right? Okay, so that is the guideline all the time. Okay, so first I take this is my null hypothesis. What is 0? There is no co-integration, right? And here you can see 26.38 is smaller than 29.68, meaning that we cannot reject null hypothesis, meaning that we accept null hypothesis. So meaning that this 0 is correct. That means there is no co-integration among the variables, meaning that our three variables such as edu, GDP and INV, they are not co-integrated, meaning that they have no long run associationship, meaning that in the long run they do not move together. And when the variables are not co-integrated, we cannot run vector error correction model, right? But we can run unrestricted VAR. Okay? Because here the variables are not co-integrated, so we shall run the unrestricted VAR, but not VECM. Okay. And also we have one more test, okay, that is max statistics and critical value, and this one is the null hypothesis. What is 0? There is no co-integration, and the statistics value 14.36 is smaller than 20.97, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis. So meaning that we accept 0, meaning that there is no co-integration among the three variables such as edu, GDP and INV. So you can see that trace statistics and max statistics, they are telling the same thing, that variables are not co-integrated. So we can run the unrestricted VAR model. That we shall do now. Okay, and we have seen that already. We have seen that our three variables such as edu, GDP and INV are not co-integrated. So we can run unrestricted VAR model now, right? Because if the variables are co-integrated, only then we can run vector error correction model. But if the variables are not co-integrated, then we can run unrestricted VAR model, and that we shall do now. Okay, so we have to go to our statistics. So we have to go to our statistics to run it. Okay, I delete all the things. I just make it clear. Okay, so I go to statistics, multivariate time series, then I choose vector auto regressive model, right? Okay, here I take our three variables, edu, GDP and INV, right? And here I take also lag 3. Suppose lag selection method has advised me to take the same lag, that is 3. So I have taken also 3 here. And time settings, here is observation and the data is yearly. So I click OK, and so everything is set. Okay, so that is our outcome of the model. You can see. Okay, this is the outcome of the model, and here you can see that is edu. So this one is the dependent variable, right? And these are all independent variable. Edu lag 1, edu lag 2, edu lag 3, GDP lag 1, lag 2, lag 3, and INV lag 1, lag 2, lag 3, and constant. And here is our coefficient. This is coefficient, and this one is the standard error, and this one is the Z statistics, and this is the P value, probability value. Okay, first I talk about 1.30 Z statistics. How to get 1.30? The coefficient 0.21 divided by standard error, that is 0.16, we can get the Z statistics, that is 1.3. So also suppose this divided by this, you can get this Z set statistics that we get all the time, and the corresponding probability. Okay, and here so so this thing will happen for all the model, right? So we have actually 3 dependent variable. One is edu, one is GDP, and one is INV. And here actually there are all the time 2 issue. One is long run causality, right, and one is short run causality, right? There are always two issues, but here in this model there is no long run causality because the variables are not co-integrated. So there is no long run causality, and here is only short run causality, right? Short run causality running from independent variable, running from independent variable to dependent variable, right? And here all the coefficient actually are short run coefficient, right? These are all short run coefficient. Okay, suppose I talk about edu lag 1. Edu lag 1, this variable is not significant. Why? Because the probability value is 19.5%, which is more than 5%, meaning that edu lag 1 variable is not significant to explain our dependent variable, which is edu. Okay, then I suppose I talk about this one, L3 GDP lag 3, right? This variable, what is the probability value? Is very small. The probability value is 0.7%. 0.7% means less than 5%, meaning that this GDP lag 3 is a significant variable to explain our dependent variable, which is edu, right? So also, but here you can see most of the variables are not significant, right? They are okay. What about here? What about the next model? Okay, I can talk about, when I talk about this one, I talk about this variable GDP lag 1. Yes, GDP lag 1 is a significant variable because the probability value is very small, less than 5%, meaning that GDP lag 1, this variable is significant to explain our dependent variable, which is INV, right? Okay. Okay, now we can talk about short run causality as a whole, right? We can talk about short run causality. So short run causality means jointly, right? Jointly they are significant or not, right? Jointly. So that we want to check now. So meaning that suppose I talk about jointly, suppose L1, L2, L3, right? These three variable of GDP, that means GDP lag 1, GDP lag 2, GDP lag 3. So they are jointly can cause INV or not. That we can check, right? And we can call it Granger causality test in the short run, right? Short run. So we can do it easily, right? We can do it easily from the Granger causality test. So I go to statistics, right? I go to statistics, then I go to multivariate time series, then I go to VAR diagnostic test, then I choose the Granger causality test, right? Granger causality test. Then okay. Okay, so this is the outcome of the Granger causality wall test. This is also called wall test. So you can see. So this one, you see, this is dependent variable, right? Okay. So what is the null hypothesis? GDP, all the lagged variable, all the GDP lagged variable, right? All the GDP lagged variable does not cause ADU. That is the null hypothesis. All the GDP lagged variable does not cause ADU. So that is the null hypothesis. That means all the GDP lagged variable, they are equal to 0. I just show you. You just check GDP ADU, right? I go up, GDP ADU. So ADU is the dependent variable. So here our null hypothesis is lag 1, lag 2, lag 3, they are all 0, right? They are all 0 to explain our dependent variable, which is ADU. Okay, so that is the null hypothesis, and the corresponding probability is how much? 1.2%. The probability, you can see the p value 1.2%, which is less than 5%, meaning that we can reject null hypothesis, meaning that they are not 0, meaning that there is a short run causality running from GDP to ADU. Okay. Then I talk about the second one, the lagged variable of INV does not cause ADU. That is the null hypothesis, and the probability value is 80.7%, which is more than 5%. So we cannot reject null hypothesis. Rather, we accept null hypothesis. That means INV, that means there is no short run causality running from INV to ADU, right? But the thing is that when I consider all, that means these two variables, right, then the probability value is less than 5%. That means that means that means we can reject null hypothesis. That means that all these two variables, uh, that means there is a short run causality running from GDP and INV to ADO as a whole, because we can reject the null hypothesis. So in the same way I can explain this one, ADO to GDP. What is the null hypothesis? ADO does not cause GDP. That is the null hypothesis, and we can reject it. And what about this one? Yes, we can reject the null hypothesis, meaning that there is a short run causality running from INV to GDP. And also this one, we can reject null hypothesis, and here we cannot reject null hypothesis. We accept null hypothesis, meaning that there is no short run causality running from ADO to INV, and this one we can reject, and here also we can reject the null hypothesis. So that is the outcome of the short run causality, right? Okay, now we can talk about the whole model. Okay, here I can show you one example, just one example. Suppose this Granger causality test we can also find out in other way. The same result we can get it in other way. So here I am giving only one example. Suppose I take this one, right? This is the value I take, right? This is the value I take, and I can do it in other way also, right? The same result I can get it in other way. So here ADO is the dependent variable and GDP is the independent variable. So I go to statistics, and here I go to the post estimation, right? I choose post estimation, I choose test, I choose test linear hypothesis, right? Okay, then I have to create the specification. So create it, and I put it coefficient in specific equation at 0, and our dependent variable I choose ADO and test this coefficient. So I take all GDP lag variable as planned, right? I take these 3. That means these 3 become 0, right? That is the null hypothesis. So I click OK. I click OK. So you can see, so this is our command, right? Lag 1, lag 2, lag 3. They are all 0, right? And the thing is that the chi-square value 11.02 and the probability is 1.16%, meaning that we can reject the null hypothesis, meaning that they are not 0. Okay, the same result 11.02 and 0.0116 we can see here. You can see this one, right, this one from the Granger causality test, and this one is the same. So there are two ways to get the result, the same result. There are two methods. Okay, now the thing is that whether the model as a whole is good or bad, that means we shall be checking diagnostic checking. So diagnostic checking of this VAR model. So I go to statistics, multivariate time series, then I go to VAR diagnostic and test. Okay, first I test about whether the residual are autocorrelated or not. That I check first. Okay, here I keep 2. Then I OK. So that is the outcome of the Lagrange multiplier test. So here I have taken lag1, lag2, and our null hypothesis is there is no autocorrelation. And at lag1 and at lag2, you can see the probability value 46.21, and here the probability value is 31.84%. So all are more than 5%, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis. So meaning that there is no autocorrelation in this VAR model, and that is desirable. The model should not have any autocorrelation, and it is not here. So the model is well specified. Okay, then we talk about whether the residuals are normally distributed or not. We have to check. So as before, I go to statistics, multivariate time series, then I go to VAR diagnostic test, then I come here, test for normally distributed disturbance. I click it, select it, and here I choose only Jarkabera statistics, right? That I select Jarkabera statistics, then I press OK. So this is the outcome of the Jarkabera test, and here we have 3 models. What is the null hypothesis? The null hypothesis is residuals are normally distributed, and that is desirable. So first I talk about our first model where edu is the dependent variable, and here the probability value is very small, less than 5%, meaning that we can reject the null hypothesis. That means residuals are not normally distributed. For the first model which is edu. And what about second model, GDP? So here the probability value is 32.59%, which is more than 5%. So here we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that the residual in the GDP model are normally distributed, and that is desirable. And the third model, residuals are not normally distributed because the p-value is very small. But as a whole, when I take all these three variables, then we can reject the null hypothesis, meaning that residuals are not normally distributed, which is not desirable. That means here got some problem. Here got some problem because residuals are not normally distributed, and that is not desirable for a model. So thank you very much for being with me for a while.